So welcome again to this new webinar of the IEA Africa University series. My name is Zakia Adam, and I'm very pleased to be here today with my colleague Alexandre Bizel, who will present to you why weather data matters for energy analysis and also present the IEA tool on the Weather for Energy Tracker. So the Weather for Energy Tracker, it's a new and free platform of the IEA which showcase the global data on weather-related variables that can be useful to everyone for understanding, analyzing, and modeling the energy sector from the energy generation to the use across sectors. So before we move to the presentation, I just wanted to give you some scene setting and say a few words on the IEA for those who may not be familiar with our institution. So the IEA has been created in 1974 after the first oil crisis. It is an intergovernmental organization that aims at facilitating the coordination of energy policies of its member countries and also beyond. And its initial mandate was first to ensure the security of supply in order to support economic growth. So since the past 50 years, the IEA has expanded its expertise to all energy sources. We collect data and do analysis on almost all countries of the world. We cover all energy sector and all technologies. For Africa, we work extensively with AFREC, for example, but also with local governments and ministries. With around 300 statisticians, analysts, and modelers that work on inside the agency, the IEA has ensured policy advice to its members and beyond. We also work extensively on climate issues and clean energy transitions, especially this year. So throughout our regular trainings, we work closely with many countries to help them improve their data collection and build models. And with the support of the European Union, the IEA is implementing a capacity reinforcement program for 10 sub-Saharan African countries. And in this program, for the moment, we are doing online courses for each country, but we also do several activities such as this IEA Africa University, and we also do bilateral work on data with the different countries. And we are hoping to start doing in-country training activities as soon as the situation allows us. Last but not least, if you want to be informed of our activities, then do not hesitate to join us on our WhatsApp group and LinkedIn community. If you want to join those groups, please send us an email and we will add you without any problem. And also take note of the next IEA Africa University for next month that will be on the electricity and gas market report. So without any further delay, I'll pass the floor to Alexandre, who will present to you our work on weather.
Thank you, Zakia, and thank you, and good morning to everyone. Today we'll be talking about the IEA Weather for Energy Tracker and some weather data, which are very important for energy analysis. So this presentation will be of 3 parts. First, why the weather data matters for energy analysis, and then I will present you the product itself. And then I will guide you through the files. This is completely free database, and all the files are available online. And then gather answer some questions, if any. If you have some questions during the presentation, feel free to write in the chat, and maybe we'll answer after. But don't hesitate to put those in the chat. So first, why the weather data matter for energy analysis? So first, on the production, on the generation side, this graph plots, so based from 2 IEA databases, the electricity generation from Australia versus the DNI, which is the direct normal irradiation of the sun as an average in the country. So one weather indicator and one observed production indicator of electricity. And we can see from this a very close correlation between those 2 indicators. Of course, as the solar PV production is correlated with the solar irradiance. So of course there are some differences between the sun irradiation and the production. It could be from the tilt angle of the solar panels, some market effects maybe, and some maintenance effects, as well as the change in the electricity capacity of the solar PV. But still, looking at the solar irradiation is already a good guess for estimating the production of renewable energy production, especially the solar PV and the wind turbine production. So this indicator that is available for all countries in the world with high granularity could already provide a good guess of potential solar PV production at the size of a country. So on the energy consumption, the weather data are also very useful linked to the energy demand. So this graph plots in y-axis the electricity consumption in France, and in x-axis you can see the temperature. So what we can see here is there is a range where the electricity consumption is not correlated with temperature, and then as the temperature decreases, the electricity demand goes up. This is because mainly of the space heating requirements. And as the temperature goes up, the electricity demand goes up as well, even though there are some other effects than the weather, but it is clear that the weather here affects the electricity demand. So as temperature goes up, the electricity generation goes up for the cooling requirements. So this profile obviously very much depends on the country considered. So if the country goes in the cold weather, so if there are high heating needs or if there are some more cooling needs, depending also on the climate, if the temperature varies a lot at a seasonal level. But already we can see that in some countries, the weather has a very large impact on the electricity demand. So there is a large impact, but the weather indicators, the weather metrics, they also vary a lot among the month in a specified year or across the years. So you can see here the cooling degree days, which is an indicator linked to temperature. So it relates to the cooling needs for Nigeria here. And you can see that there is a huge variability of this across the month. So spans from 60, 70 degree days on average per month to above 200. And there is also a high variability across years. And if we look at the sum of the cooling degree days, so at an annual level for Nigeria, the difference can be as high as 28% across the years, considering only the 20 most recent years from 2000 to 2020, which means that the cooling needs would be as variable as 28% across the years. So it may be relevant also to exclude the effects of the weather when looking at the energy demand, as those 28% are only due to the weather and would not relate to the structure of the economy, for instance, and the total capacity addition of the cooling appliances. So the weather indicators are key to analyze or exclude the effect of the weather on the energy supply and consumption. So as we saw, the weather has a huge impact on electricity, energy supply and demand. So there is a methodology that we use here at the IEA for doing some temperature correction of the energy demand. So the temperature correction is applied to the indicators that are thermosensitive. So those are the space, heating, and cooling. It very much depends on the weather, of course. And the objective is to decouple here the effect on the weather with the other effects linked to the economy itself. So It goes with a simple ratio between the heating or cooling degree days in the considered time in the considered year over an average over a reference period, which is here from 2000 to the latest year. So looking at an actual indicator, so you can see on this plot for a set of IEA countries, of 20 IEA countries, the evolution of indices of some end-use indicators. But let's focus mostly on the green and the purple curves. So they show here the same thing, which is the index of total residential energy consumption per dwelling per year. However, the green curve is the non-temperature corrected, is the observed value, whereas the purple one is the temperature corrected value. And what we can see here is as the weather impacts the energy demand and the weather differs between all the years, the green curve, so non-temperature corrected, sees some, let's call it noise, is less smooth than the purple curve. And especially in year 2008 and 2009, sorry, you can see a spike in the total residential consumption per dwelling. Okay, there is a spike, but if we apply the temperature correction, the purple curve, we see that there is no longer a spike. So the effect of this spike is linked to the weather. So likely a very cold winter that induced some increased energy consumption on the residential end. And if we apply the temperature correction methodology, you can see on the purple curve that the story is completely different. The energy consumption was not increased for residential dwelling. That didn't mean that the efficiency of the heating may be decreased. No, that was linked to the effect of the weather. So once the effect of the weather is excluded, corrected, we can see that the downward trends continues. So these structural trends may be linked to efficiency gains and on the heating and so on. So now that we have seen the importance of the weather indicators linked to energy, I will then go through the weather for energy tracker itself. But this slide is just to give you a sense of a non-exhaustive list of how the weather data, the weather for energy tracker, is used by IEA analysts. So feeding the World Energy Outlook and the Global Energy Review flagship reports, mostly the temperature indicators, the heating and cooling degree days are used for modeling purposes. So first, to normalize the energy demand. So normalize is linked to doing this temperature correction. So to exclude the effect on the weather, to keep only the structural effects. So to build a baseline for the projections. It's also used to understand the impact on the weather, on the demand and the emissions. And so to analyze as the climate evolves, this effect. And also to assess the distribution of population in need to cooling. The observed data sets are not always enough for doing some modeling, as we know that the population in places in need for cooling is to grow up, as well as the climate is evolving. Looking at the weather data set enables to understand what could be the need for the evolution of the need for cooling in the future as the population and climate evolves. The temperature and cooling degree days are also used in the climate resilience policy indicator reports. So this to analyze the evolution mostly of the climate. So the long-term indicators, the evolution of the long-term indicators linked to the weather, to understand the resiliency of the countries against the evolution of the climate. And the irradiation and the wind speed data, so on the generation, on the supply side, this time, are used to calculate the technical potential for solar and wind generation. So using very granular data, so using data at an hourly level. So now that we have been through the importance of the weather indicators, I will now show you the weather for energy tracker database that we produce here at the IEA. So this is a free, completely free platform that provides some high resolution weather indicator to the overall energy sector. So this targets statisticians, researchers, modelers, analysts all around the world linked to the energy sector. So the primary weather variables are extracted from the Area 5 model from the EU Copernicus system datasets. So the primary data are not produced by the IEA, they are coming from Copernicus. But then at the IEA, we are selecting, manipulating the data, so to keep the relevant and doing some computation, so to build the relevant indicators targeted to the energy sector. And this is developed in collaboration with the CMCC, that has expertise in the climate and weather analysis. And this is to be updated every quarter. So the last update was in January 2022 with data until December 2021. And following this link, so I can't see the chat, but maybe if we can put the link of this in the chat, the link of the page, so you can have a look. But you have the link here shown in the presentation. So there are 3 tools for accessing this database. There is first an interactive map that enables to visualize easily the distribution of the indicators in a very much visual way, and linked to a customizable CSV download platform. So it is easy to make a selection and then download the selected data. So I will present you all of those tools in detail later on. There is also an interactive Excel file, so that includes the selected and most relevant indicators at the country level. And there is finally a data repository that includes the full data set. So for the most data intensive needs with the very comprehensive data sets. So there are over 50 weather variables, so primary, so directly extracted from Copernicus and derived indicators. Temperatures, they are the minimum, maximum temperatures, as well as dew temperatures, wet bulb temperatures, and some heat indices can be used for some analysis. There are, of course, the heating and cooling degree days with several methodologies, the standard methodologies, as well as Eurostat one, several threshold reference temperature, the 65 Fahrenheit used in the US, as well as the Eurostat thresholds. There are also all the wind and the sun relevant indicators, and the other primary indicators such as humidity, precipitation, so the primary variables, but even that can be used for assessing hydropower production, for instance, and looking at precipitation, snowfall, runoff, evaporation, and so on. So data are available at 3 geographical granularities. So first at grid level. So the grid level means the world is meshed into, is split into about 1 million points on the Earth with 0.25 degrees of resolution. It means the resolution is as precise as a square of about 30 kilometers of size. So it's really to look at local, at grid, at small effects on the weather, if looking at the evolution of the indicators at a very specific place in the world. And we also compute some national and subnational averages of the indicators. So when modeling the full country data. So the national indicators are available for 240 countries and territories, so covers the whole world. And the subnational indicators are available for 7 key countries for now. So the national and subnational averages, how the indicators are computed. So there are 2 main ways to aggregate the weather indicators across a country. The first methodology is to use surface weighted average, which means assuming that the indicators are evenly distributed across the country. So for instance, if we want to look at a country, the sun irradiation potential, one may want to just do a simple average through the whole countries, assuming, I don't know, that there is equal chance of solar PV, solar panels to be implemented in the country. So this is a simple surface weighted average. However, if we want to look at as we have looked at the cooling needs, the cooling needs goes close to the population, where the population live. So we don't want to do just an average across the whole country when looking at heating or cooling degree days, but we want to weight those weather variables by the distribution of the population across the country. So this is called the population weighted average method. And if we look at the case of Greenland, which is maybe the most extreme case, the population tend to live in the places that are not the coldest, say in Greenland, close to the coast. So the average temperature of the country in 2020 was minus 17 degrees. So surface weighted average. If we look at the whole country. However, if we look at only where the population live, so the average temperature relevant to estimate the heating needs for the countries, the average is minus 3 degrees. So depending on the indicators, one of the 2 methods can be available for the indicator, or the 2 methods could be available if relevant. So this database comes with three time granularities. So data are available at yearly level, monthly, as well as daily level. The time series goes from the year 2000 to the latest month. So latest available month is currently December 2021. And the database also includes climatologies and anomalies. So a climatology is the mean of a monthly indicator over a reference period. So the reference period selected here is year 2000 to 2019. And the anomaly is the difference between a value and its related climatology. So the climatologies and anomalies are very much used in the weather data sets, and mostly on the forecast, for instance. So usually the anomalies are forecasted while the climatology is the base train, the baseline for the indicator. So all of this is available from the dataset. So finally, we have a user's guide that was built to be user-friendly, so that has all the details you may need, such as how to access the data, what is the coverage of the database and the definition used, what are the sources, and what are the methodologies that are used. So I will now present you the database itself. Okay, sharing. So I encourage you to, okay, to click on the link that I put in the chat, so to browse the database. So this is the main page, and from the main page you can see this very nice map at first. So the map presents the data at several levels. So here, by clicking grid, we can see the grid data, so the local, the finest in terms of resolution data, in terms of geographical resolution. So you can select your variable by clicking the menu here. Not all the indicators are available from the map. There are more indicators in the data repository. However, this is to give a flavor and to give a selection of the most useful indicators here. And if we look at cooling requirements, okay, so this is December 2021. You can change here the month as well as change the resolution. So if we look at yearly values, we can see here where there are the highest cooling needs for year 2021, for instance. The data are also available at national level. So here, by hovering the countries, you can see directly the values here. And by selecting, okay, split big screen. And by selecting one or two countries, you can have a plot of those two countries here at the bottom pane. So daily values, monthlies, as well as yearly values, as always. And so you can cherry pick some few data from here already, but you may want to download more of the data set. So there is here a configure download button. So in the configure download button here, you can make your selection of still, okay, cooling degree days, all regions. I may want to select all regions, and yearly data, say from 2010 to 2021. And I can download here the values. And we have here a CSV file that is produced with all the data that we want here. And you can find for all countries in the world here, the cooling degree days with a reference temperature of 18 degrees Celsius for the time range selected. And the cooling value is here. So yeah, this is mostly it with the map. So as you can see here, the temperature is available for surface weighted average, for instance, as well as the population weighted average. So you can see by browsing in the map here the effect on the population distribution on this effect. It's quite, yeah. So the next tool, and I may want to stop sharing. The next tool is the Excel highlight file. Okay, here. So in the Excel file are the basic definitions of the database itself, of the link to documentation of the sources. There are here the definitions of the countries covered, as well as the indicators that are included here. So not all indicators are included in this Excel file. This is just to use the most important metrics. It is not possible, given the size of the data, to put everything in an Excel file. For this, you would need to use the configure download or the data repository. But still, there are here the monthly data. So you can go from cooling degree days to heating degree days and precipitations. And the monthly values by countries are included here. And you could select the value or the anomaly as well. So the anomaly here means in March 2010, in Afghanistan, the precipitation were below the average for this month, while in Albania, it was above the average by this X amount. There are also the climatologies here linked to this. And there is finally a plot of the values. So if we select here, I don't know, Germany, you could see here the cooling needs that are in the middle of the years, of course, and the heating, which is way higher than the cooling needs, for instance. And you can see the variability here between years and between months. So it's easy to visualize the data and then access the data that are available in the monthly data tab. And the last way to access the data is from the data repository. So all of the links to this are in the main page. So in the main page here, you have the map, of course, and the data repository link is just here, and the highlights file is just here, and the user guides is here in the end. So the data repository is just where you can do some bulk download of the data. So here, grid data. So grid data, local data are just here, and I can go to monthly values. And here you can see all the files for cooling degree days, heating degree days, wind, and so on. So all the indicators are included here. There is one file for one indicator. And the format of the data for grid, those are not Excels, those are not CSVs. The data are so big that here it's 1 GB of data. So the format is netcdf, which is a specific data format that is used by the weather when doing some weather analysis. The netcdf format is the one commonly used that can be plotted using Python, R, and so on. However, looking at national and subnational data, we propose here, we suggest to have both the netcdf and the file in CSV format. So the daily file in CSV format are quite large in size, but this is okay. So the daily values for all countries in the world can be downloaded in CSV as well. So I wouldn't do it here now because the files are huge, but still everything is included here for all the data intensive needs. Finally, we have the user's guide that summarizes everything that was discussed now. So in the user's guide is an overview of the product, what is the data coverage, when will it be updated, and there are some here screenshots here explaining how to access the data from the map, what is included in the map, how to download the data from the interactive map. It also details a territory view here, what are the variables included. Same for grid map. It also details, the link of the data repository, what is included, what are netcdf files, links to documentation about netcdf files, if useful, and similarly for the interactive Excel file, detailing how to access this. Our data source, of course, everything is transparent and in theory could be reproduced, and all the definitions of the indicators. So here the definition of temperature, you can see this is the 2 meters mean temperature, and it matches the X item of the ERA5 primary data set. So it's all transparent here. And then there is the methodology. So going from the definition, you can see more details on the methodology here. And if I click here, I see, okay, heat index. This is our methodology for computing the heat index and the values that are used. and so on for wet bulb temperature and all the indicators, how they are computed. And is in the end the section on the references, of course. So it's all transparent, and we try to build here a user's guide that is not too long document. So we hope it would provide an easy access to the data, to the whole energy sector from the user guides and also from all the tools that were developed here. So that's it for the presentation here.
Thanks. Thanks a lot, Alex, for this very detailed and comprehensive presentation. Please, for the participants, if you have any questions for Alex, please don't hesitate to drop your question in the Q&A box. Or if you want to share also your experience using weather data and other climate indicators, please go ahead and share your experience with us. We are very interested in knowing what you are currently doing in your country. Are you using, making use of such data for analysis? Are you interested in using it? How do you find our IEA tool? Do you think it's useful to you in your work? Also, if you have suggestions for us for improvements, don't hesitate. And yeah, so don't be timid and don't be shy to take the floor. I think you already have one question in the Q&A box, Alex. So he says, in Ethiopia, the weather is very good, so no need for cooling and heating system. So how is this webinar helpful for countries that don't have needs for cooling and heating?
Yeah, thanks for that question. So yeah, we talked a lot on heating and cooling, cooling degree days, because those indicators are really key for cold or very warm countries. It's really something that is used by a lot of modelers. But the use of this database is not limited to heating and cooling needs, of course. So we have here, I have mentioned quickly that it could be used for estimating the renewable potential, for instance. So the renewable energy production, that could very much be applied to Ethiopia as well. That could also be used for the extreme weather events. So as this is used in the climate resilience report for the IEA here, for instance, it's not looking at heating and cooling needs, but looking at the wind, at the precipitation. So really the extreme weather events is something that can be used from this database to do some analysis on the resiliency for all the countries. So there are many potential uses of those data, and it's not possible to list everything. So maybe the heating correction temperature doesn't apply to Ethiopia for sure, but as the first, yeah, that could be renewable production, that could be extreme weather events, or that could be looking at the distribution of the weather indicators throughout the whole countries. Could be linked to renewable production, precipitation, so on. So yeah, it's not only about heating and cooling, but I would say it's up to the users maybe to use the full potential of this database. We cannot think of all potential use of this database for now.
Thanks, Alex. I think we have a participant who would like to take the floor. So Camilu Lawal, would you like to say something? I've just given you the permission
Hello,
to
can
speak.
you hear me? Good
Hello.
morning. Hello, can you hear me?
Yes, we can hear you.
Thank you very much. My name is Kamilu Lawal, and I happen to be a researcher about microgrid and renewable energy resources in Nigeria. And I want to thank you for this opportunity. It is important that we have more than enough tools for analysis, because most importantly, when you're into design, you need enough data, especially the weather, for your analysis so you can get appropriate results. But there's something I want to understand from the weather for energy strata. From the analysis I've seen here and from the presentation, I've seen that it is more of a solar and wind systems that is being analyzed for energy and weather trackers. But in Nigeria, there's still more than enough potential for hydro resources, which are also renewables. We are thinking about microgrids with renewable energy, which are from micro hydro sources. So, what are the opportunities for other energy sources like water? I don't know if you understand. So, my question is: do we have some weather data for those people that are willing to go into micro hydro or small scale hydro resources or hydropower resources? Thank you very much.
Thanks, Camilo. So Alex, did you understand well what he meant? So he was talking about in Nigeria, they are doing analysis on micro hydro. And so he wanted to know if with our tool, we could do analysis on water. And this is what I understood. The communication was not great. So
Okay, that's also my understanding. Thank you for your question. So regarding hydro, we have the total precipitation in the database here that is available at grid, so local level. So, well, assessing the hydro potential is something complex that needs some, geological data. It's also linked to the topography of the place. So the database itself here, the weather database, is not something to be used alone for assessing the potential of micro hydro, I'd say. But we have here the total precipitation available at grid level, so at local level. And some researches show that the total precipitation, looking at the variability of precipitation, could be an indicator to the variability of hydro production in some places. So it very much depends here on the country, on the place, but I would say linking some researches, maybe some literature. The precipitation here of the weather database may be something useful for the modeling and for assessing the annual variability of micro hydro, for instance. But this is something, maybe not immediate, but looking at some existing literature on this, precipitation may be something that you want to use. And and in case you know that this is here available, but yeah, this is maybe not enough to just start a full analysis, but yeah.
Yeah, thank you. I understand your point of view, and I really appreciate all your support you have been doing. Thank you very much for this opportunity. Thank you.
thanks, Camilo. We have another question from Aminata Garbo. Can we get some of these tools to be used in analyzing different countries' energy data? So that's.
I'm not sure I get the question as as detailed. Those tools here, they are available online for free, and they include all countries. So
yeah, you can download different countries, make comparison. Everything is freely available.
Yeah, looking at the highlight Excel file, for instance, you can just go to the website and download the Excel file, and here you have all the data available for all countries. So it enables already, if you're interested in looking the wind across countries, it's already here available. And then doing some analysis, you could benchmark, compare countries, I guess. But yeah, it should be all available for all countries in the tool presented. Yeah.
Please resend the link to the energy tracker. So I will share the link again.
Yeah, Ibrahim, you have it in the chat at the very beginning of the chat.
Yeah,
Maybe
I'll
you can
put it
re-put
in the Q&A as well. So other participants, if you want to take the floor and share also, like the Nigerian participant just did, tell us if you have projects, ongoing projects that use weather data, or if you have plans on future projects. And so we have Aminata who would like to talk. Please.
Hello.
Hello.
Good morning, everyone. This is Aminata from Sierra Leone.
From where, please? I didn't.
Sierra Leone.
Okay.
Aminata from Sierra Leone.
Yes, please go ahead.
For our own country, we are more focused on solar energy, hydro, and wind. And also, we are having challenge in data analysis, especially in the solar sector. So I was just asking some of these tools because I'm unable to see like Sierra Leone data on the link provided. So that's why I asked if my country, if I would love to do some data analysis in their generation, especially in solar, if it would be good for me to use this tool to get some data.
Okay. So Alex, do we have data for Sierra Leone in the database?
Should be, yes. In the map. Yeah, so again, it covers all country. Let me check. It should. We don't have like gaps. Yes, I see Sierra Leone here in the map, so it should be here as well on the grid and in the highlights Excel file.
Okay.
So it means yes, the wind speed, the wind capacity factor, the solar radiation should be here. Then to derive the potential of renewable, the production, you may need to manipulate a bit those data to use some literature. So this data set that we have is only weather variable. So that's why we have this global coverage. So you may need to do another layer of maybe computation to really match exactly what you have. But already, yes, I mean, we do compute some national data for Sierra Leone, and it's something that you may you may want to use. Yeah.
Yeah, like for I was thinking of doing a project in integrating those three energy sources of greater energy, like solar, wind, and hydro. I'm working on a research on that and integrating those three energy sources.
I don't, if I understood well, you're also looking for energy data for Sierra Leone, right? I didn't hear well what you meant. So I don't think we have energy balances, statistics and balances for Sierra Leone as a separate country in our IEA database.
For energy balances, I don't think so either,
yeah.
but we could.
But I think from the UN, yeah, from other international organization, maybe you could find from the UN, probably you could get energy statistics.
Okay.
Yeah.
Yeah, the energy statistics are challenging as well, so that's why, yeah, the weather data can be a proxy sometimes or complement the energy statistics, but yes, energy statistics still remains the basis and can be challenging to get sometimes.
So, in research.
Sorry, I didn't hear well.
If you provide assistantship in the research basis.
If we provide, I didn't hear.
Assistantship, like guides for students doing research.
So you're asking if we can provide assistance to students for what?
For research on energy.
Okay. I mean, if you know some students who need some specific data from the IEA, of course they can contact us and we can provide some data and some guidance on how to use those data and guide them on the available data that the IEA have. So this we can do, but it depends. I don't know. It depends on what the students is looking for, I think.
Okay, no problem.
But
So
for sure,
is there any link we can reach out in terms of data?
Yes. So if you have questions related to the climate and the weather data, weather for energy tracker, Alexandre had shared on the screen, it's the emissions@iea.org. Let me write it in the chat box. Oh, Alex. Yeah, so you can send email to either the Africa program. This is for this. And then Alex just dropped the emails, emissions@iea.org. If you have specific questions related to this tool.
Yeah, please follow up with to this email address maybe, and we would
and also
get in touch with relevant colleagues if
yeah.
Yeah.
And if you have if even after this session you have questions on the tool while you're trying to put your hands on it, and please don't hesitate to write to us for guidance and also to discuss the different projects that you might have and what kind of analysis you want to do with this data. We are very interested to see the different uses of our data.
So I will. The link I saw here is Africa program at IEA.org.
Then just after Alex just wrote, okay, so sorry. I will put it to everyone. It was just to the panelists. Now, normally you can see it.
Okay, emissions at IEA.
Yeah.
Thank you so much. So,
thanks to you.
Reaching privately in using the tools, I can also reach out to these emissions link.
Yes.
Okay.
Thank you.
Thank you so much.
We still have a few minutes left before the end of the session. So if other colleagues would like to take the floor to share your experience with us and ask questions, please take this opportunity. No more questions. So while we wait to get some questions, so this session has been recorded and will be put on YouTube by tomorrow or before the end of this week, and also you will have access to all the material on the website. If you have questions, write to Alex on emissions@iea.org. And please let us know if you think that this kind of sessions on the tools that we have at the IEA is useful to you and interesting. Usually the IEA Africa University series, it's mostly on IEA latest reports, and today it's a kind of an experiment that we are doing on presenting to you and the different tools that we have at the IEA that are freely accessible and that can be useful to you on your work. So please let us know if you think this is useful to you, and if there are specific IEA tools that you would like us to have an event on. Please let us know on the Africa program at iea.org email. So how do I join IEA on LinkedIn and WhatsApp? So here, please, if you want to join the groups, write to us on on this email, and we will let you know. We will let you know the different steps. So on the LinkedIn page, we usually share the different events that we have or upcoming IEA activities and reports. And on the WhatsApp groups, it's by country. So we have a WhatsApp group where we share information among us, but just within the country. So I don't see any more questions. So thank you everyone for listening to us. And thanks a lot, Alex, for joining today and sharing the work that you have been doing on the weather tracker. And so I say to everyone, have a nice day, and see you next month for another event of the IEA Africa University. Thank you, everyone. Bye.
Have a good day. Bye.